Mutation is the driving force behind diversity. It is the process that brings about new genetic variations with each generation. But how often does mutation produce a new trait variation? For that, we need a real-world example, like the rock pocket mouse. In a population of light-colored mice, how often will a pup be born with dark fur? We can do a calculation to come up with an estimate. Scientists know from studying rock pocket mice and other animals that in one particular gene called MC1R, there are at least 10 different locations where a single base change will generate a dark fur allele. Mice have 2 alleles of every gene. To have dark fur, a mouse needs just 1 dark fur allele. That means in these 2 alleles, there are 10 times 2, or at least 20 possible places where a mutation will make a dark fur allele. To calculate how often the dark fur variation will come about, we need to know a few things. Mutation rate. How often do mutations occur? Population size. How many individuals are in the population? Reproductive rate. How many offspring are born each year? Let's talk a little bit about rates first. A rate is a comparison of 2 different amounts of something, using different units. We use rates in our daily lives for many different tasks, like making sure we're going the speed limit, calculating how much money we've earned doing a job, or converting dollars to pesos. Rates are expressed as fractions. Rates commonly involve units of time, which are most often in the denominator. If 1 is in the denominator, we can simplify the units and say things like 30 miles per hour. A mutation rate is the number of mutation events in a genetic region per unit of time. The genetic region can be just 1 base pair, or 1 gene, or 1 chromosome, or could be the entire genome. The unit of time can also vary. For instance, the time unit could be per cell division, or per generation, or per year. Mutation rates are different for different organisms, and they can be tricky to figure out. It takes scientists many years of observation to have enough genetic data to determine an organism's mutation rate. Fortunately, mice have been studied over many generations. Mice have a total of about 2.8 billion base pairs, all potential places where a mutation could happen. Scientists have figured out that every generation, 1 base out of every 185 million of those bases will be mutated. So what does that mean for a population? Well, here's another way to look at it. Say 185 million mouse pups were all born at once. If you pick 1 specific base and look at it in every single one of those pups, just 1 of the mice in your new population will have a mutation in that base. And this is true for every base in their genome. That is, if we look at a different base, just 1 mouse out of 185 million will have a mutation in that base. Of course, this isn't literal and is a statistical average for a theoretical population. But we can use this information to calculate how often we will see a certain mutation. So that takes us back to the fur color mutations we're interested in. Remember that in our fur color gene, there are 20 possible single base mutations that will result in a dark fur mouse pup. Statistically, that means there will be 20 mouse pups, each with 1 of those single base mutations in our theoretical population. So 20 out of every 185 million pups will have 1 of those mutations. To simplify and get 1 in the numerator, we can divide by 20. Now we know that 1 out of every 9.25 million pups will have the dark fur color variation. That's the mutation rate specifically for our fur color gene. So what's our reproductive rate? To figure that out, we'll first need to know the population size. Actually, to be more specific, we're really only interested in the female part of the population because that's where the mice offspring are going to come from. A typical population of rock pocket mice has about 5,000 females. Each female gives birth to at least 5 pups per year. So, if all 5,000 female mice give birth to 5 pups a year, That means there will be 25,000 new pups every year. Now we have our reproductive rate. So, we figured out that every 9.25 million pups will have a dark fur mutation. That's the mutation rate. And now we know every year we get 25,000 new pups. That's the reproductive rate. By multiplying these two rates, we can isolate the time unit in years for the dark fur pups. Using unit cancellation, we can cross out mouse pups, and then multiplying this fraction across the top, 25,000 times 1 is 25,000. And 1 times 9.25 million is 9.25 million. Now we have 25,000 dark fur pups over 9.25 million years. Doing this division, we now have 1 dark fur pup per 370 years. So a pup with a dark fur mutation in this gene should come around once every 370 years. Now, 370 years might seem like a long time, but consider that rock pocket mice have been around for a very long time. Rock pocket mice first established themselves in New Mexico 500,000 years ago, around the same time that early hominids started using stone tools. If you divide 500,000 years by 370 years, you can see that, based on our estimate, a new dark fur mutation could have occurred over 1,300 times since the mice first established themselves in New Mexico. If just one of these pups grew up to have pups of their own, they have a good chance of passing their dark fur allele to some of their offspring. And if those dark offspring reproduce, they can pass the allele to their pups. Within a few generations, the population could have many mice with dark fur, which is what we see today.